Sorry about that. Okay. All right. So if you do the vertical line test, and Allie, I'll send a picture of this one, this page here later. Then if it touches at 2 points, it's not a function. Okay. I skipped this up here. The variable X is called the independent variable. I think I said it, but I didn't realize that he had this fill in the blank here. Because it can be assigned any value from the domain. The variable Y is called the dependent. Did I spell that right? Or is it A-N-T? Is that right? Okay, good. Doesn't look right. All right. So, and this is kind of, I can explain the independent and the dependent. Now, this looks like it's really hard, but it is really easy. What you need to know is these two things are the same thing. When you see this big fancy notation, you just think why. Just think why, okay? Okay, so, but you're going to, and this says, reads y equals f of x. The way you read this is f of x. This means it's a function. Before, when it looked like y equals 3x plus 1, that's a line, okay? It's a linear. If you were to graph it, it's a line. If you had this, x squared minus 5x minus 6, that's a parabola, okay? So like this, if you were to graph it, it would look something like this. If you were to graph this, I don't know exactly how it would look, but it would be a parabola like this, all right? What a function is it groups everything together. Whether it's a line, whether it's a function, whether it's a cube root, whether it's a square root. It's just treated the same. Just when you see this f of x notation, you think y. Because see, this and this mean the exact same thing. Okay? So, right here, you'll notice that if it was an ordered pair, like in this case, you'd have x and y. If it says something like this, you'd have x and f of x. Notice all y. Input, output. Input, remember when we did this? And we just picked some values. You'd graph it by table of values. You'd say -1, 0, 1, 2, maybe. And depending on this value, when you plug it in, depends on what y is. Okay? So that's why x is your independent, because you can pick anything. But once you pick it and you plug it in, that's where that independent comes from. Okay, now we're going to move down to here. What does this mean? Here's what you're going to do. We have evaluating a function. If f of x, that's how you read this, equals 3x plus 1, find each of the following. When you see f of 5, that is telling you, this is telling you what x is. This is saying that x equals 5. I want to know what my y value is going to be when x is 5. Well, what do we do with that 5? Just plug it in. You say 3 times your 5 plus 1. 3 times 5 is 15, plus 1 is 16. Your answer is 16. Every your x's. If it's 15 different places, you plug it in, yes. And we'll get to one down here. We probably won't do practice. We'll do this and this, the examples today. Okay, well, now they tell you, okay, well, what is your function going to equal when x equals -4? So you just plug it in. You say 3 times -4 plus 1. 3 times -4 is -12. Plus 1 gives us -11. And by the way, this in our minds, this is your X. This is your Y. Input, output. Okay. This is your X. This is your Y or your output. Input, output. It's going to, you're going to have to know that kind of for later on. They get harder. Not that hard now. Okay. Like this one right here. It gets harder. But what this is telling you that X is now A plus H, which what is that? Our input or our output? Input. You still, if these were numbers and you plugged them in, same thing here. You still take your 3, put your input into it, which is A plus H. And now what is your Y is going to be the answer to this. What do you do with the 3? Just distribute it. 3 times A is 3A. 3 times H is 3H. Plus 1. This is your X value. This is your Y. Now again, X are inputs. Input.
But like,
Oops.
we
Input.
switched to green, but at the same time,
And input.
in everything, so like was trying to control things, but we were like, oh, you got this. Like, it's
These are all your
it was
outputs.
just a hilarious combination. We were doing
Here, and here.
we like thought it was
Okay. Input, output. X is input, Y is output. Now, notice we even put that right here. All right, I'm going to skip the practice, but I'm going to go to here because it's going to be more difficult. And I'll tell you, nope, we're not doing
like it
that.
was literally
Okay.
like
Again, same thing.
school everywhere.
What is my X value in this problem right here? 6. So X is 6, which is my input, right? So wherever I see an X in my function, you're going to plug in a 6. So you're going to have 6 squared plus 3 times 6 plus 5.
It was hilarious. Definitely a fun story.
Yes, you can plug that into your calculator. Or you can do, this is 36 plus 18 plus 5. 54, is it 59? Check me, those of you that have your calculators out, please.
She had to go show everyone her makeup.
Tell me if I'm wrong or right, either way. Get your calculators out. Oh, I will say this. If you learn your store button, it's much easier on these problems, like in this particular case. Now, I'm going to tell you right now,
Just below the
if
10.
you do not do math on paper, because yes, I don't have to do all. I do not have to write these steps down.
She's
But because I have done it for you,
literally,
it is not a problem whatsoever. Some of you are going to get on the test because you know what you do? You take your calculator out and you don't do any math on paper. If you don't do math on paper and your test is on paper, you get screwed up and you don't do well. And you go, what can I do to raise my grade? Okay? You know, there's lots. I don't know who does it on paper and who does it. But I know you all that aren't the ones that do it on paper. I did in math. That was about it. Okay. We'll put it this way. I know what, I've always been honest with what I did and what I didn't do. Okay. In high school, I did everything on paper. Of course, we didn't have computers back then either, but we weren't allowed to use calculators either. But that's why I know it so well too, at the same point. But I show you calculators because they make you buy these calculators, so we might as well use it. All right, what I'm going to do is I'm going to hit 6 store X. But here's also the difference, because guess what?
And she was like, oh, yes, that's perfect. And so, moral of the story, like, I'm doing how many weddings I've
So
done. I
guess
think
what I would do when I first started teaching?
like,
I would take all my
you
advice
express
and
some
and I would write
opinion.
every single step down, which was this.
She
Then
did
it was this part.
it.
And then I had to learn how to use these calculators. So I came up with different ways to use the calculator. So I'm checking my handwritten work this way. So I stored 6 under my x, and now I'm going to type in x squared plus 3x plus 5, and I get 59. And that is what I got. But I was able to do it both ways. Now, yes, does it take a little bit longer on your homework? Sure. But I'm telling you, this is not one of those subjects that you can just get through this class and never use it again. How many of you are waiting until the fall to take 1130 or 1710, your next math class? How many of you are waiting until the fall? Yeah, because a lot of you won't take summer school. So guess what? You got to remember this stuff, because we expect you to remember it when in the fall when we see you. Okay. So anything to help you out, do it right now. Okay. So right here, this is telling you that x is equal to -5. So wherever you see an x, you're going to plug in -5. So you're going to say -5 squared plus 3 times -5 plus 5. Now, this is where you really should be able to do this without your calculator, because some of you are going to mess up right here, even if you use your calculator, if you don't use the store button. This is positive 5. Right here, this is 25 plus a -15 or -15, right? Just going to leave it as that, plus 5. This is going to give us 10 plus 5 is 15. So what I'm going to do is I'm going to store -5 under my x, and then I'm going to bring that back up, and I get 15. I'm just using my calculator to check to make sure I understand the process. Because order of operations is that important. Okay. 0. Guys, I love it when they tell me that x is 0. Because watch, 0 squared plus 3 times 0 plus 5. That gives me 0. That gives me 0. So I only have 5. Again, my inputs are over here, and my outputs are here, which are my y values.
Yeah. Yeah.
Outputs. Okay.
But these are what they look like.
I want to see something real quick, because they get harder. And I don't know, I'm going to do one more problem on this set. By the way, functions, they like to use F, G, and H. They'll use other ones like R and C in a word problem. But like, notice this was an F of X. This was a G of X. But here's what I want to show you, because this is what you'll need no matter which class you take. And I don't know if you'll see it in your homework. You still should be able to handle it. But I'm telling you, I have people who do this. First of all, I want you on your paper. Let's do it right here. I want you to put, I want you to work this problem.
Yeah. Also,
I just want you to square a plus h. It is not a squared plus h squared. It's not. I've gone over this and over this and over this.
stylist was showing me pictures from her wedding back in 2020.
Because some of you are sitting there not knowing what to do. Guess what? I taught this.
Actual at all.
I need you to know it, because when I get you in the fall, if I don't, or the next instructor picks you in the fall, you need to know how to do it.
It was So bad.
because it's part of the difference quotient. But what you do, what would you do if I wrote it like this? That's what that means, right? Now, some of you look at that and go, I don't know what to do. There's your problem. You're in trouble. What do we use? Okay, so you're going to say
I was always the one that would
A times A is A squared.
okay.
A times H is AH. Now this one right here, guys, when you say H times A, you can write it as HA, but I'm going to write it as AH because I want it to look like this. But you can write it as HA, you just need to know it's the same thing. And then H times H is
It's like talking about plastic looking
So,
things coming out of
now we
my
have A squared plus 2AH plus H
I
squared.
do think it's kind of gone out a little bit.
Yeah.
But I was fooling it.
But, guys,
I had them for years and
again, it's you have to retain this stuff. And some of you work your butt off.
Got like
It's like half and half. Okay? Others of you do the homework and you go, oh, I thought you do it. Okay? I get that part. I understand it. But you also, it's going to come back and bite you if you don't understand this whole thing. And this is one of the probably week 2 of the semester, week 2, and we're still going to use it because now I'm going to add this D is going to be D of 8 plus H. And when you do that,
because it creates this little
you're
like,
going to
shelf.
say, take your input, square it, plus 3 times your input plus 5. Where before they were numbers, now you're going to do the A plus H. Now, look right here. See that part? We just did this part right up here. That's why you have to know it. Okay? And so this, we already have our answer is A squared plus 2AH plus H squared. This I have to distribute. I get plus 3A plus 3H plus 5. And nothing, I cannot, I can't simplify it any further. So that's my Y. That's my output. Okay, it's not really a Y because how do you graph it? Okay. Now, I know you're sitting there going, why do I ever have to know that? You're going to learn how to do that in 1130 or 1710 for those of you taking either of those classes. Okay, and then you learn how to use the formula that uses this. Then in the next class, you actually learn when to use it and why you need it. Okay, so this type thing you need for the next class plus the next class. And I don't know if you have any homework like that, but even if you do, you should be able to handle it. Okay, I'm not going to do this practice. Right here, we're just going to look at this one, example 5. Figure at the right shows the chances of surviving various ages once you reach 60. The function this and this models the chance as a percent that a 60-year-old will survive to age. Here it'd be 70, here it'd be 80, 90, 100. Okay. Which model serves as a better description for the chance surviving to age 70? Okay, first of all, let me look. What is X? Does it say? Is X the percent, right? Which model serves as the best description for chance surviving 70%? 70. Okay, right here, what you're going to do is for the linear function, you're going to plug in, you're going to say f of 70. And for the quadratic, I know it's a quadratic because it's an x squared. Linear is just an x. You're going to find g of 70. So again, now here, I will use my calculator to make my life easier. You're gonna say negative 2.9 times 70 plus 286. Negative 2.9 times 70 plus 286. I have an 83% chance. Okay. If you make it to 60, you have an 83% chance of making it to 70 on this one. On this one here, you're going to say 0.01 times 70 squared minus 4.9 times 70 plus 370. .01 times 70. I don't know why I'm not using my store function, but I'm just not for whatever reason. Plus 370. And I have a 76% chance. Now, the reason they're asking this, which one, didn't they say which one's a better model? Which model serves as a better description for this graph? Okay. Well, here's 70. Where does it fall between 80 and 90, right? Here's to reach 70. So which one was better, the first or the second one? The first one was closer to what the graph says. Okay. All right. So this one is the better.
Second, okay?
I like that one. I like those chances better. Closer. All right. Example 6 is even easier than what we've been doing, but it looks confusing. All you have to do, remember, okay, it says function, find the indicated value. What does this -1 stand for? X. So what does the answer to that stand for? Your y, right? So if x is -1, what is your y? 0, or your f of x, or f, in this particular case, it'd be f of -1. This is how you would write that. This one would be your f of -2 equals 5. Okay? So this one would give us 0, right? What is our f of 0? What is our y function? 3. Okay, now, and you're going to have one like this on your test. And you will see it. So this is your x, this is your y, right? Or what they call f of x now, right? Well, now it says find x. X equals what when, what is this for? What does that stand for? Our y. So what is our x value when y is 4?
Too much, and then
Okay. X is equal to
another trial. Yeah.
questions on that. All right. This is what we really get into in our next class. Okay. I can't stress it enough. Vertical line test, I've already talked about that. Okay. If any vertical line intersects a graph in more than one point, the graph is not a function. Okay, it can only cross in one thing. So right here, tell me, is this a function? No. See how I hit it in 2 points? It doesn't matter where I draw my line. It's always going to hit it in 2 points. So this one is no. Because it says use it to describe which one's a function. So I'm going to do no, yes and no. Okay. What about this one? Yeah, I don't care. No matter where I draw my vertical line, it only crosses in one. It only hits it in one spot. What about this one? Yes. What about this one? No. Because again, it's going to hit in two places. Okay. All right.
This should be, okay.
I'm going to come back to this one. Okay. Because I think this stuff's more important. All right. Example 3. We're now going to be using a graph. Now, this is what? What does this -4 stand for? My x. So I want to know, what is my y value when x is -4? Well, if you go left to -4 and you go up here, that is the point -4, +2, right? So what is this equal to? 2. This isn't hard. It's just different. And you need to practice at it, okay? Right here, what is my y when g is 2? -2. You go right to, down to. It is this point right here, 2, -2. Well, x is 2, y is -2. What about g of -10? What is it? It still is going to be 2, right? Because -10 is way down here, and this just stays constant. All right, so it's still at 2. And what about g of 10? -2. Because -10 would be way down here, right? And it's still going to be down here at 2.
Take whatever you
Okay. Okay, this is where it gets tricky. Because what are they giving? What information are they giving me here? They're giving you the y, and you have to find the x. So when y is 1, what is my x? It looks, okay, here's 1, right? I come across here, be at -2. Okay.
I know kind of once you notice that, like.
And then here at -1, what would it be? This, yep, +1, because my x is 1. It's going to be right here. Okay, it's right here and right here. Because again, what you're asking is basically, is when this problem right here is being asked, you are asking, what is the point this, basically? And right here, all right, it's what is the missing value? It's the x value. All right, interval notation. All right, we've got interval notation, we have set builder notation, and we have to graph it. Okay, now I always teach the graphing. Then you do interval notation. Now you would use this when you have inequalities. Okay, less than, greater than, less than or equal to, greater than or equal to. Here's what you need to know is, and we use interval notation all the time in your next class. And I say your next class because I don't know why you take 1030 if you're not taking 1130 or 1710. So I'm assuming everybody's taking that. Okay, we use this all the time because it's short. It's in points and it's all the points between it. It looks a lot like an ordered pair, but we know if it's asking for interval notation, we know it's not an ordered pair. Okay. Basically, in interval notation, if it's a parenthesis, it does not count it. It's kind of like, you know, an open circle and a closed circle. It's the exact same thing. Like this here would be if you have some value A and some value B, you before would have had open circles and it's everything between those. Okay. In this case, where you have brackets, that means
didn't take a photo.
If
after what-
before you have a number A and a number B, brackets means it's included. You would have had a filled in circle, and it's everything between. Okay? So what this one here is saying is, it says, express each interval in set builder notation and graph. Okay, well, it gives interval notation. Let's graph it, and then we'll do set builder notation. Okay, so we have an open circle at -1. Let's see. I don't know. Let's do 1, 0, 1, 2, 3, 4. If you want to fill in the whole thing, it's fine. I'm just, for time purposes, I'm pretty lazy on my graphs. In fact, I usually don't have this. See mine? That's usually how it is. Okay, we're going to have an open circle at -1. And we're going to have a closed circle at 4. Okay. And what this is saying is all the numbers between it will satisfy whatever we're solving for. Okay. That's what we would before. Now, in Pearson, if it asks you to graph, which I can't remember if it asks you to graph or it just gives you graphs. If it is, it won't have this. It will have parentheses and a bracket. It would have a parentheses here and a bracket here and everything between. Okay. I just want you to know that open circles go with parentheses, closed circles go with brackets. Now, what this means is this is all your X values. All X can be negative. Well, it can't be -1, but it can be 0, 1, 2, 3, and it can be 4. Okay. So how you would do this in in set builder notation, inequality would write it like this.
Beautiful lashes done, and I'll add a little bit.
And that's the inequality.
But
Notice X is between -1 and 4. It doesn't have an equal sign at the -1 because it can be -0.9999999, but it can't be -1. It will not satisfy it. Okay. The difference between an inequality and set builder notation is you do this. You put an X in front of that and a line coming straight down, and you put it in braces. That's set builder notation. Have we ever talked about set builder notation in here? Okay. You read this as the set of all values X.
Make it not look as like.
Actually, I usually just say all values X. And this line here stands for such that.
And we did, I didn't know.
X is greater than or -1 is less than X, which is less than or equal to 4. Right here, 2.5 to 4. Let's put 2 here. Let's put 3 here, 4, 5, and I'll put a 1 right there. Because they are brackets, would they be open or closed circle? Closed. So I'm going to put a closed circle in between 2 and 3 and a closed circle at 4, and it's everything between it. And again, they may use they might use brackets in Pearson like that. Depends on which class I'm teaching. All right, so you would say 2.5. You just rewrite this, and you have to use less than or equal to or just less than. But because these are both filled in, it's always an equal sign there. And all you have to do is put an X such that and put it in braces. That's all you do. Now, with infinity, let's just put -4 here, -3, -2, -1, 0, and 1. Okay. It's an open circle at -4, and it goes to a positive infinity. Here is negative infinity, here is positive infinity. It's everything this way, everything that way. With infinity, Okay,
That they really helping you.
you would use parentheses, negative infinity and positive infinity. The way you write this is x is greater than -4, and then you just do x such that. Okay,
Yeah.
I have not gotten all the way through 8.2. So Wednesday, you will take your test, okay? And then Friday, we'll finish up 8.2 and start 10.1. Yes.
Any adjustments, so.
Okay, those of you that took the test early, I have graded them. If you want to come in and look at
Yeah.
it again, which I highly suggest, because I did not text everybody and go, hey, great news. Okay? It's up to you. If you're happy with what you did, see it. But if you don't, no, you do not have to come if you're not going. But those of you that took it, I'm going to hand it back to you and you can look it over before you hand it back in. And I'll regrade it.
If you want.
If you want to start over, you can start over, yeah. Although you just wasted my time grading it the first time.
Ground zero.
Plus, I feel like it's.
Okay, never mind. Never mind.
Don't count. If I didn't end this thing, it's so. So easily. So if you're so experienced. There, because what I'll do is I'll just add a little bit of a concealer on top.
And then I remember the jail time. It's like, you guys,
Just yank it. Feel bad. Smell.
Yeah, what more?
Like,
One more thing, come
what's
on.
going
put it
on?
down.
What is going on here?
Okay. I'm gonna start again. You were doing it. So we're gonna do it, okay? All right. And I cannot remember them, but I can. I will. Look at the review, 'cause I'm like, you guys do X's on, because then you're gonna, and then, but then again, I don't know what I'm gonna do with you guys on it. But I'll text you. Look for a text tonight, okay? I'll let you know, because I remember yours. But, okay, yeah.
I'm just a little confused. What is the, why is there system practice?
Brackets included. Okay,
Oh.
it can't, like, let's say the problem read. When we're solving inequalities, 3x plus 1 is greater than 10. Okay. In this case, you subtract 1, right? Divide by 3, and you get x is greater than 3, right? Here, it would be, if you were doing interval, it's not included. So it'd be parentheses, 3 to infinity. And infinity is always parentheses, okay? If it was this, that's when it would be a bracket, because 3 will make this a true statement.
Okay, I know, because over there, when it's not included, we put the bracket upside down. You know what I'm saying? Can I have?
Yeah, sure.
Or it's not included?
Yeah.
Like this.
Backwards.
Yeah.
Really?
That's not included 3. That's why I was a little confused about the parentheses.
Okay. If I see that on your test,
You could,
I will probably ask you about it. Because I remember, and I'll be like, does that mean it's included or not included? So this would take the place of a parenthesis, right?
exactly. When it's not included, you just put it upside down. But I'll try remembering the parentheses thing, but if I forget about it,
I'll ask. Yeah,
okay.
okay.
Thank you very much.
And again, it's not necessarily, but it will screw you up in Pearson.
Oh, really? So
I don't think they'll, Yeah, they'll count it wrong, I think. I'm
Okay.
pretty sure. Let me know on that.
Okay, perfect. Could you simulate the domain